MCQ 11, we're going to take a look at the spontaneity of a reaction. Wherever there's the spontaneity word here, we'll be relating it towards delta G. So we're going to have two expressions for delta G. The one that's found in energetics is going to be your enthalpy minus temperature multiplied by entropy. But if let's say this happens to be a question that was relatable to electrochemistry, it will be equal to negative number of electrons in the redox equation multiplied by Faraday's constant and multiplied by E0 cell. Now the question here, we do have the cycling through words like entropy as well as endothermic, exothermic. So this could be seen to be using the energetics expression for delta G instead of the Faraday's, which is going to be for the case for electrochemistry. So on situation number one, we're just going to take a look at which of the statement is correct. So based off statement number one, when the reaction is endothermic, there's going to be a positive value for delta H, and it has a negative entropy change. That's going to be a negative value for delta S. The reaction is spontaneous at all temperatures. Alright, so let's take a look at that. So let's say we're going with T equals 0. Now this is going to be absolute 0. We can say that my delta G will actually be equals to delta H, because 0 times delta S is still going to be 0. And since delta H is actually positive, I would say that the reaction is actually going to be not spontaneous. So again, the question mentioned over here that this is at all temperatures and 0 Kelvin is considered to be part of the spectrum. So I'll say that this is not a true statement. So when temperature is 0, no reaction is going to happen at all. So statement number 2, if the reaction is exothermic and it has a positive entropy change, the reaction is spontaneous at all temperatures. Again, just going to show you get T to be equals to 0. Delta G will then be equals to delta H, which in this case here is negative. I'll say then yes, is considered to be spontaneous when temperatures are actually extremely low. But now we're looking at all temperatures. So if let's say I'm going to have an elevated temperature, if temperature is high, delta G will be equals to delta H minus T delta S. Now delta S is already positive, but if you take a look at this function that's at back, a negative value of temperature multiplied by a positive value of my entropy is still always going to overall be negative. So when temperature increases, that means that the magnitude of negativity also increases. So delta H itself is already negative. A negative minus the negative value here, it just becomes a larger negative value. So delta G is negative. So I would then say yes, is considered to be spontaneous as well. So we have investigated a low temperature as well as a high temperature. My option number 2 is correct. So option number 3. So I'm just going to put this at the top here. So when the reaction is exothermic and it has a negative entropy change, the reaction is not spontaneous at any temperature. So now it's going to be quite a big word here, is at any. So if T is equals to 0, same thing, delta G is equals to delta H. And then you will see that in this case here, your delta H is negative. So that means that delta G is negative, is considered to be spontaneous. So if the question here were to say that it's not spontaneous at any temperature, then this is going to be wrong, because at absolute 0, it is not spontaneous. But already just as a sense of spectrum, if temperature were to be elevated here, delta G is equals to delta H minus T delta S. So again, taking a look at the profile overall, I have a negative enthalpy and I have a negative temperature over here with the negative in front of the T. So the value here will always be positive. So if T is high, I will have a very big positive value. There's a chance that this positive value is much bigger than the negative value of the enthalpy. So delta G could likely to be more than 0, and this is not spontaneous. So I'll say that for this profile here, the spontaneity actually decreases as temperature increases. So instead of saying it's not spontaneous, it's only not spontaneous at high temperature. So the only statement here is going to be statement number 2 or option C.